So here is another problem of work energy theorem, which we can solve by simply applying the work energy theorem. But there are a lot of concepts which will get clear if we think slightly deeper about this question. Okay, so first let me solve straight away applying the work energy theorem. So the question says the velocity of an object moving along a straight line changes from 5 meter per second positive to 5 meter per second negative. Okay, so object is actually moving in a straight line, right? And let's say its velocity initially is towards right, 5 meter per second. And finally, the object goes to zero velocity and comes back. And finally, it has a final velocity, which is in the other direction. So how much is the work done by the force, right? Clearly, the object was moving towards right, so force must be acting towards left, right? So to change that velocity to negative, right? So the force must be acting towards left, okay? And then the object stops at all the time the force is acting, right? So at this point, the force is still acting and it is carrying the providing acceleration towards the left, and finally the object has a velocity towards left, right? So the work energy theorem simply says that the work done by the object is going to be equal to change in kinetic energy, okay? No potential energy involved, so simply going to change in kinetic energy. So we can find change in kinetic energy is going to be my initial final kinetic energy minus initial kinetic energy. Okay, so what is the final kinetic energy? This is half into m into v square. Okay, so v square is going to be 5 square, and then with minus sign, half into mass into again minus 5 square. Okay, and as you can see, both of these quantities will be same irrespective of the mass, so this is going to be equal to 0. Okay, both will have the same value, right? Because 5 square in the negative and positive is same. Okay, so we can say the work done by the force is equal to 0, and that is the correct answer. Okay, but let's think about this, how you can get confused in this question, right? So first thing first, you must think that because the force is acting on the body, it must have done some work to stop it, right? So that work done when it's trying to stop the object to the zero velocity, force must have done some work, right? So force does some work from positive 5 to the 0, right? And this time, because the force is acting in an opposite direction to the velocity, it is going to be a negative work, okay? But when the object changes direction, now the force is acting in the direction of the velocity, right? So this time the force from 0 to minus 5 is doing positive work, okay? And because the change in kinetic energy in both the cases is same, this positive and negative actually cancels up, giving you the net work done, right, by the force equal to 0, okay? But the force is doing some work partially when it is going in this direction, and then again doing in this direction, okay? So net work is 0, but force is doing work while the object is moving in one direction and then doing a negative work in the first time and positive work in the other direction, right? Another way to simply think about this is that we can find the work done by the force by simply looking at the force dot displacement, okay? In this case, because the velocity is the same, right? The body is going to cover the same distance, okay? The same distance in both the directions. First in this direction and then in this direction, so it is going to arrive at the same location, okay? And as you can see, the displacement is going to be same when it is going from this direction to this, and then opposite displacement in this direction, net displacement, because the object starts from here, right, and comes back again to this point, the net displacement, right, is 0, okay? Starting from the same location, coming back to the same location, the net displacement is 0. So this is also going to give you the force into 0. The work done is going to be 0. Okay, so now we have verified our answer using two methods, and also thought about how the force is actually doing the work. In the first case, the object was moving towards right, it stopped the object, so it did some work, but again it pushed the object in the other direction because the force is acting in that direction. It did some positive work, and both the magnitude is same, hence the net positive and negative. So work done by the force in this case is equal to 0.